we're going to build a model. And then we're going to take the population projection, and we'll see what happens per capita. If the per capita is going down in real terms, it means the country is getting poorer. If the per capita is going up in real terms, the country is getting richer. Right?
Making sure you don't miss anything.
Now, what country was I doing last time?
Netherlands?
Netherlands.
Yeah.
Is that the one you found?
Yeah.
About 30 minutes.
I think so. No, I didn't. I mean, you were.
It's awesome.
Yeah. You are the most interesting human.
He's too dangerous.
I find him dangerous. No, he's a hardware.
I
might be the only person alive other than you. Person again, I would love to have that. I would like to just have no responsibility whatsoever. I miss not having responsibility. And again, I was living at home with my mom.
It's got a week of the lady. Oh, and he's driving the nice.
You can also need that.
But it's
Like, seriously, dude, I put like speakers and the subwoofer in this thing, and it will kick ass.
Does it have a Hemi?
Does it have a Hemi?
It has a Hemi.
No, it was
Then-
a Mitsu.
Really?
Yeah, it was an Expo. But it was
good.
really Expo, so it had this like front stage seating.
Sign sheet?
Like, it was like-
You all good?
I'm good. Just like, it was like a sound bar. It was so awesome. I was the only person who liked it. The girls did not like it.
The girls did not. The girls did not appreciate it.
That
They did not respect the minifigures.
the first thing I'm going to do is get the data from the Netherlands.
My computer is doing something. I'm stuck.
Did you never get anywhere?
I'm not talking about it. I just started trying to and done everything.
We're going to get the GDP by expenditure is constant. In US dollars. The Netherlands. And we'll take, I'll just take all these and run it, put it in the yearly.
Then GDP.
Well, here is a selectivity column. And we go by item. All the data. Now we'll pick the columns that I need. We don't need final consumption. We don't need fixed.
So which years do you need? All of them?
And now we'll sort.
I dare you ask a question.
Send it.
Yes.
I'm gonna take all the years now, but I will cut off the one, easy to do it this way than to pick out each. And then we'll download.
My computer's broke.
Which one is? Yeah. I have all these years, but I only want the years beginning savings, so. 1995.
Your check back.
National Council.
Class.
Is it every year?
Very much church.
Tell us to choose that every year.
Alright, you know what? I'm gonna try to do
I just remember I wrote myself notes on how to do this. So
The first one is C. This one is G.
Professor,
Yeah.
are we getting the GDP in current prices?
No, constant.
Constant?
Yeah, constant. Constant price in US dollar. I. X. N. The last one is GDP.
Why?
Now, the first thing I want to do is move Y over to the left side. This, copy it over here.
I don't know.
So highlight this 6 times. 3, 4, 5, 6. Equals. We'll highlight the first row over here. Then we'll hit the divide sign. We'll divide by 1 million. 1, 1, 2, 3, 4, 5, 6. Control, Shift, and so now I have the GDP in millions. I'll copy it over here, put it here, and paste.
Perfect.
I have to paste that.
Damn, I'm so good. Copy this one.
Paste that. So now I have it in values, which I can get rid of. Get rid of the decimal place. So now I have the data I need, the basic data to repeat. Now, I want to get my population data as well. Go back up here.
That's all right.
Let me see this. Go back here. Let's go pick up the population. World population prospect. And with the total population, both combined, new data. and the other one in the country is Netherlands. Here's Netherlands. Now I'm going to sort this data. Here I have the population data of the Netherlands starting at 1950. Download this.
What database were we doing?
You gotta get it.
What database was it?
2010.
I want these numbers. Copy these. Back over here. Put it down.
All right, I got this from you.
Now, all of this I want to save so I can work with it. Okay?
I remember what country.
Go up here where it says save. File.
Did you
Save as.
That was France. That's what we did, yeah, I forgot about that.
Let me see. I want to save it as. Not desktop. Not download.
You're so awesome.
Document. Well, the code is nothing.
This isn't one. National Council of Reduction. GDP by type of expenditure. GDP by type of expenditure. Select sort.
Where do I see my documents up there?
Select to the column. Item. Update.
Just scroll down.
Yep.
Okay.
But this one was from 95. This one's from
So, I don't know, you care about it.
That's all.
Select columns. Not final consumption expenditure, or it was final consumption, right? Or we have consumption expenditure.
Good. Now we have my document.
Awesome.
Now, these start with 1950. This is the year 1950. They go by 5 years, all the way up to the year 2100. So this is
That changes it.
1950.
Sorry, did we choose final consumption or household? Household? Still.
I want to take the copy and bring them over here. And then I want to paste transport.
So it was household, general, government, gross capital for information, exports, imports, investment, so it's the 5 plus the 1. What did you just do?
Copy.
Everybody wants to do it. Under this?
Yeah, this one's okay.
Copy that. Put it here. Paste. What place? Right. Well, delete that. And that will create a column. So this will be equal to 5 plus.
Need a base, need a base.
It gives it to you for every 5 years. So we have these population figures in thousands every 5 years. The first thing I'm going to do is put them in millions. It's going to be equal to. Now, if I want to go to millions from thousands, what do I have to divide by?
Millions, thousands?
By 1,000.
Yes. That's what I said. Sure. Just happen.
Are we gonna go over this?
No, pay attention.
Yeah, my computer is off, so I'm still trying to catch up.
Well, right now, we're not, maybe later on we'll work.
It's okay.
Here we have the Netherlands. This is population
Mike.
in thousands.
Did you pick grass fixed capital formation or the other one?
No, the first one, not the second one.
Grass capital formation.
P-O-P 1,000.
Is the country.
And this will be P-O-P 1 billion. So we see in the Netherlands in 1950 they had a population of 10 million people. When we get up to 2100, they project a population of 17 million. But now, in 2010, there's 16.61 million. Right? So these are population projections, which we're going to use.
Where did we get this?
We say in economics, when we take someone else's projections and use them in our model, we say they are endogenous. Exogenous, sorry. These are exogenous. E-X-O-G-E-N-O-U-S. Population exogenous, which means they don't come out of the model. They're done by another model somewhere else.
Or is European?
No. We're talking about no opinion. Opinions are out, that's the political side. Sure. Economic, no issue. Now, these come from demographers. Demographers have ways of projecting the population for very long periods without economics. And it's based upon the people who are already born and the birth and death rate that they know. But they make mistakes. But their projections are much more accurate than economic projections. So here we have a nice set of projections here. Now when you go over here, we're going to eliminate this guy. The first thing we're going to do, let's get rid of this. Label it capital. Netherlands by expenditure. All right. And this is in constant. Let me put millions first. Millions of constant U.S. dollars. So this way, people know what kind of units we're dealing with. So this is our basic data source that we're going to work with. Now, the first thing we're going to look at is what we call an exponential model. There are two ways we can look at this. There's a number of ways, but the most common way is by an exponential model. If we put time on here, and GDP over here, all right? You might think of it as going in a straight line up like that. That would be a linear model. But if it has any kind of curvature, sort of like this is an exponential model. Normal projections over the long run are done with extrapolations are done with exponential models. Because even though it's almost linear, it usually has some kind of curvature to it. And the exponential model is gotten by doing the following. We see that y is equal to some constant e to the minus b times t. So this is the first year. All right? And y is some year out in the future. That's why it's called an exponential model. If you take the log of y, this is the log. Let's put plus up. Let's put plus up. Log of y is 0 plus b times the log of t. So this b is called the instantaneous growth rate.
How many minutes are left? Started at 6.
It gives you the growth rate at time t. It's fixed, it's a constant. So instantaneous growth rate. This is just a constant. Call it a. So in order to get this model, we'll have to take some logarithms. Now we'll start by putting a label on time, calling this t. And we'll create the column for the log of y. And that's going to be equal to ln, open parentheses, y. And then you close that. Control, Shift, Enter. And you drag that down. All right. And now we can get the log of t. So this is going to be equal to, actually, this is not the log. When I take the logarithm of this comes out to be bt. Sorry. That's bt. So we don't need to think of it. Just bt. what we need. All right. Now, the next step is to get the regression package out. Now, let's see if we have it. We have it. There's data analysis.
This is divided by 9. This is.
So we go down here until we get regression.
Okay.
And it's looking for the input Y range. The input Y range is the log of Y. That's what's on the left-hand side over here. This is the input Y range. This will be, the T will be the X range.
What's the Y range? Oh.
That's that, right? Now, this explanatory variable will simply be this. And we have labels in this. And the output range, I'm going to put as a convenience, I'm going to put right over here.
Yes.
Everybody see what I did on this?
No, I don't. What happened?
It's this. Whatever is on the left-hand side of the equal sign of your equation, whatever it is. In this case, on the left-hand side of the equal sign, we have log of Y. Follow that?
Yeah, got that.
And X is T?
The X is the explanatory variable. In this case, the explanatory variable is time.
Okay.
Time, okay. But shouldn't that be?
Any other questions before we go on?
Shouldn't the time be a 1?
Now, this is some very important information I'm giving you, because now I'm making you into a scientist.
Good.
You're making equations to describe a phenomenon. That's science.
Like science.
And now I click OK. And there we go. So here's the equation that we get.
Wait.
The log of Y is equal to this number minus 36.4876 plus this number next to the T, 0.024. Times T. Now what did I tell you that we call that number? What did I call it before? I wrote it on the blackboard. You got a short memory. Instantaneous growth rate. Instantaneous growth rate. What is the instantaneous growth rate when you look at this? What does it tell you?
What instantaneous growth rate? I don't know what we're doing. I'm still trying to figure out what just happened.
What is the instantaneous growth rate? It's 2.48%. About almost 2.5%. In other words, the Netherlands has been growing steadily at roughly 2.5%. If you multiply it by 100%, yeah.
So you had the value of t multiplied by t? Or is that t just to identify that?
No, you multiply t by this number and add it to this, and you'll get the logarithm of y.
Okay.
We're going to do that now.
Okay.
Everybody understand what the instantaneous growth rate is?
No.
Good. Now,
Actually, I thought we could put it just 7.1%.
we're going to make a new table in which we put everything in 5 years.